Christopher Tappy Carmen, and this is the Physics 2211 Lab 3, Black Hole. Some content. The content of this lab report includes the purpose, the physics behind it, the code, error, and any question that may arise. Purpose: in part 1, the aim is to be able to create a computational model that simulates the mass of the black hole, and then in part 2, we're creating a computational model where a spaceship is affected by uh, a solar system, basically, with a planet and the moon. So physics. So we know that change in momentum, or the rate of change in momentum, equals F net. And so we know that G, the force of gravity, is the F net. So force of gravity equals dv dt. We know that dv dt equals change in momentum over change in time. So we know that we can set these two equal to each other, and then eventually solve for m2, which is what we're trying to find in terms of m1. All right, a code demonstrates this. First, we were given that the mass of the star was 2 times 10 to the 30th. And then for every initial, we just use um, we just set the initial velocity vectors here, and then final velocity vectors there. For momentum initial, we just do v initial times the mass of the star for both of them, and then delta v. Yeah, this is just a change in velocity and change in momentum. And then to calculate dp dt, we have to do change in momentum over change in time, and that's what we do here using these previous values, and so on. And then so we set our net force equal to that dp dt right here, and then that's pretty much it for the perpendicular force. And then over here we have we calculate the we use the equation I previously stated before to calculate the actual mass of the black hole in terms of the object of the mass 1. And this is our demonstration of the code. Alright, so for part 2, we use the same force of gravity equation. But we have to also use the velocity update and position update formulas to update our code. So the speed is set by, I just guessed and checked, and then eventually got the correct speed. But you just have to solve the gravitational force from like everything, like the ship on the moon, and then the moon to the ship, and the planet on the ship, and then like planet to the moon. Just find all the net forces acting on each and everything, and then eventually you just update each of their positions and velocities in base of the net force that's acting on the object. For example, the moon has F net on moon divided by this is just a velocity update formula, and then ship as well has the same thing, and this is our code for that. All right, before the questions, some errors that may arise is that computational models are not 100% accurate, and like it's not going to specific values. Like it's just a rough estimate. And then velocity, like I said, I guessed and checked, so it's not, for part 2, it's not like completely 100% correct. All right, so questions. What does it mean for part 1? In your analysis, you should discuss how the net force and parallel and perpendicular components are different from the rate of change of momentum. They're not different because they add up to F net, and we know F net equals dp over dt. So they're equal to each other. It's just that parallel and perpendicular components just show us like what's pulling on it towards the center and changing its direction versus what is changing its magnitude and speed. and momentum is just showing us that all together. The imaginary system has a black hole, a star, a planet, and a moon. If you wanted to predict the motion of the entire system, what would you need? We would just have to include the force of the black hole and how, like the net force it's causing on each of the objects. Thanks for watching.